Okay, today's plan, we are going to start factoring polynomials today. We've gotten to the point where we know how to multiply polynomials and combine them. So first we're going to label, we're going to understand what each component of a polynomial is. And we're also going to learn about how to break down and basically work backwards from what we were doing last day with the the multiplying polynomials. Okay? So let's get started. The quicker we get this done, the quicker you can start into working on the right notes. Once you get this done, we can start working on the assignments. There's 2 assignments posted on your website. Yep. You might just need some water. It might need to be damp. Alright? There we go. Okay, let's get started. We know how to multiply polynomials. We learned last day with regards to kind of how to combine, what to combine, and why we can't combine x squared with x when we are, I guess, adding up our like terms. Okay? We're actually going to break down each term based on these 5 definitions or components. Okay? So I'm going to base it on a simple polynomial term. We're going to use that to help us solve the term above, or the polynomial above. Okay? So the first part, who can tell me what they know is a variable? What is a variable? A letter. Yeah, in math it's a letter. What does that letter represent?
An unknown number.
Wow, an unknown value or number, absolutely. So in this small example, 3x squared, what is my variable?
X.
This is our variable. In the polynomial 4ab minus 2bc plus c squared minus 8, what are all of my variables? Can I have more than one variable?
B, C, C, S.
Yes, I can. What types of what variables do I have here?
A, B,
A,
C, C.
B, and C. I don't need to put C, C. I can just put them in each type of variable that I've got. That's fine. Perfect. Terms we kind of talked about last day. How do I know that this has 3 terms in it? Okay, how do I know that there's 3? What if I did this? If it was 2xy, there's now 4 things. 4 pieces. How do we know this? It's still 3 terms.
Thanks for saying.
You're welcome. How do I know?
Between addition,
Yes.
subtraction.
All of my terms get separated by either addition or subtraction. Okay? Because I have 2 additions here, I know I've got 1, 2, 3 terms. In my example of 3x squared, how many terms do I have? 1. Do you see any plus or minus? No. So this is 1 term. How many terms are in this example?
3.
1, 2, 3, and 4. There are 4 terms here because they are separated by this guy, this guy, this guy. Nice helpful hint, if you see 3 plus or minuses, you have 4 terms. For the most part. Okay? Degree is a different one. Degree talks about the exponent. Degree is in each term which is the highest exponent, or which term has the highest exponent, or the highest amount of variables in that exponent. For this 3x squared, you're looking only at the exponent of the variable. What's my exponent here? 2. So what can you say about the degree of this term? It is degree what? Degree 2. If it was x cubed, it would be degree
3.
If it was x to the 5th, it would be degree
5.
5. What's our degree here? What's the highest exponent you see?
2.
2.
On what one?
This whole piece. The whole polynomial. What's the highest exponent you see?
2.
2. So it's degree 2. Who can tell me what a coefficient is?
Oh.
Go ahead, Abiel.
A number on its own.
The number by itself, that's a constant.
A number beside a variable.
A number beside the variable or in front of a variable is typically our coefficient. In this example, 3x squared, where is our coefficient, or what is our coefficient? Just the 3. X is our variable, degree is, our exponent is the degree, this guy is our coefficient. Always the number in front of the variable. Okay? What coefficients do I have in my polynomial term above? 4ab minus 2bc plus c squared minus 8.
That would be 4 and
4, 2,
2. And
I got one more.
8. No. C? I don't know.
What, if there's no number in front of a variable, what's assumed that the
One.
number is? 1. Why not minus 8?
It's a constant.
Minus 8 is a constant. There's no what, Rika? There's no variable by 8 or negative 8. That deems it a constant. Okay? We know exactly that that term is the number 8. Or minus 8, depending on how you look at it. Okay? If we don't know what these values are, any of these values, okay? Any of these terms, because there's variables beside them. We know for a fact, huh? Yes, I'm recording. You got it? Good? Alright. Yes, we know this number because there's no variable here. It can be written as negative 8, it can be written as positive 8. Just know that the number with no variable is a constant. Is there a constant here? 3x squared? No, there's no number after, so it's just one term. Questions on that?
No.
It's not necessarily going to be assessed, but it's something that you're going to need to know over time, that when I start talking variables, coefficients, degrees, constants, that you know what those terms are. Okay? Good? Alright, let's keep going. And let's introduce our concept of factoring in the first kind of layer. The first layer of factoring for this piece in 10C is factoring common factors. Remember when we did greatest common factor? What were we doing when if I asked you to find the common factor of 15 and 35? What am I doing here? Collecting all of the
Common or lowest common factor.
Common numbers.
I'm trying to find what? In 15, if I'm doing my T chart, what am I looking for?
Lowest common multiple.
Equivalent.
What does it multiply? What two numbers multiply to give me 15? What are all of the factors? So when I say factor, I mean what two numbers, if I multiply them together, gives me 15. And then we usually start at the lowest number, which is 1. It'd be 1 and 15. 2, does 2 work?
No.
3?
Yeah.
3 and 5, 4? And then 5 has already been done, right? What about 35? 1 and?
35.
Does 2 work? 3?
No.
4?
No.
5?
Yes.
And 7. 6 doesn't work. What is the biggest number that is in both of these terms? 5. Why this number is significant is because not only is this the greatest common factor, it's also a number that I could divide out of both 15 and 35. Okay? That's what we're doing here in this example. We are actually taking common factors of both negative 9y squared minus 6y minus 6, and I'm completely taking them out of this equation. Okay? So right now, all I want you to look at is the numbers. I got negative 9, negative 6, and negative 6. Do you think that there's a number that I could divide out of all three of those numbers evenly? 3? I think 3. So here's how I'm looking at it. I'm going to divide by 3. Could I divide by negative 3? Yeah, because this is what's going to happen to all of these terms.
Positive.
They're going to turn positive. So I'm going to divide the entire thing by negative 3. How I represent that is what I call factored form. You're going to hear factored form an awful lot. That's how all of the factoring polynomials and factoring binomials look. They look like factored form. That's what they're called. You're going to see a lot of it between now, grade 10, or grade 11 and grade 12. So factored form looks like this. Because I'm dividing and I'm taking out a negative 3, my first bracket looks like this, the number that I'm taking out. I've decided that I can a common factor of negative 9y squared minus 6y minus 6 is negative 3. Who can tell me what negative 9 divided by negative 3 is equal to? Positive 3. Now, I've got y squared here, and I'm dividing it by negative 3. Can I divide y squared by negative 3? No, so I just leave it y squared. Okay? If for some reason I had a variable here, it's a different story. We'll talk about that in this example, okay? My next one, negative 6 divided by negative 3 is equal to what? 2. I have a y, so I keep my y there because I'm not dividing a y, right? Negative 6 divided by negative 3 is equal to positive 2. That's my answer. That is factored form, and that is breaking down a polynomial into its simplest terms. Okay? Make sense so far? Now, when I look at an example like this, where I've got 12 x to the power of 3, y to the power of 2, minus 20 x times y to the power of 5, plus 8x to the power of 2, y to the power of 3, what number comes to mind when I can factor out of 12, 20, and 8? 4. I can take 4 out of all of these. Now, what else is common between all three terms?
2.
Yeah, 2, but we don't need 2. We're already dealing with 4. We're already dealing with the numbers. Numbers are dealt with.
X and Y.
We have x and y in each of these terms, right? x, y, x, y, x, y. I should be able to factor out an x and a y. Here's the thing. Mathematicians are lazy. If they can take shortcuts, you guys should be writing this down, not drawing silly little drawings. Zach, thank you. We're lazy. We like to take shortcuts. If I don't have to do this more than once, I won't have to. If I look at, let's just look specifically at the x variable right now. What exponents are beside each x value? I have an exponent of 3.
Why? Oh,
I have an exponent of 1. And what's the last exponent for x?
2?
2. What is the lowest exponent that I have?
1.
3, 1, or 2? 1. That means I should be able to take at least 1x out of all three of these, correct? What happens if I take more than 1x? Do I have enough x's here? If I take 2 x's out, I can take 2 here. Can I take 2 x's out of here? I can take 2 x's out of here, but I can't take it out of this one. I have to be able to take one thing, at least one thing out of all three. So having said that, I can take 1, so I'm just going to put a little 1 to remind me. What about the variable y? What are my exponents? I've got y to the power of 2, y to the power of 5, y to the power of 3. What's my lowest exponent that I can take out? 2. That means I can take out at least 2 y's in each term. We remember, how did we, when I had to multiply x and x together, what did that give me? X squared. Y. I'm multiplying. When I have two numbers with the same, two values with the same base, I'm just adding their exponents. If I'm dividing, which is the opposite, what do you think I'm going to be doing I'm going to subtract the exponents this time. So let's go through and let's figure out what our final answer is. Again, in factored form, so my first step, what's my first bracket I'm putting in? 4x, y squared. Okay. What's 12 divided by 4? 3. What is x cubed divided by x? If I have 3 x's, I'm dividing 1, I'm taking 1 out, I have x squared. Remember, when I'm dividing exponent or variables with the same base, I look at their exponent. I have 3, I have 1. 3 subtract 1 is equal to 2. What about y? Y squared divided by y squared is just anything divided by itself is what? 2 divided by 2 is 1. Y squared divided by y squared is 1. I don't need to write the y anymore, right? So 2 divided by 2 is equal to 1. That's the same as saying y squared divided by y squared. And if we use the same exponent piece, we said that we're subtracting, right? What's 2 subtract 2? 0. Any exponent to the power of 0, remember this rule? It's always 1. Anything to the power of 0 is always 1. Again, mathematicians are lazy. If we don't need to write a 1, we just assume it's there. Okay, so we don't have to, we can cancel out, the y's. I'm going to put that to the side just so we keep it there. Let's keep going. So negative 20 divided by 4 is what? Negative 5. X divided by x is just, nope,
1.
1. Thank you. So do I have to write x down? No, I don't have to write anything. Y to the power of 5 divided by y to the power of 2 is equal to y to the power of 3. I go to the last one. 8 divided by 4 is equal to 2. X squared divided by x is just x. Y cubed divided by y squared is 1. Everybody good with that so far? Does anybody not get what we're doing so far? Make sense? A little bit? Alright. I want you guys and girls to try this one. Okay, what's the curveball right now? What's that? I have numbers, but what do I have now? How many variables do I have now? I have 3. Okay? Try to factor that as best you can. That is a z, sorry. My z's can sometimes look like s's or 5s.
Or an exaggerate line.
Well, at least that tells you it's a z. Not yet. And it's not really like FOIL. We don't like using that FOIL term, but we'll get there. I'll show you why.
That's why I did it in the book.
In the booklet?
Yeah. Is that okay?
Yes, it's okay. I'm going to show you a different way to look at it though and visualize it. FOIL is a process. I'm not a big fan of FOIL because it's a memorization tactic where I can help you today hopefully understand why you're doing FOIL. Okay?
Okay.
So I want you to break that down. Your first step should be try to figure out what common factor is between 18, 36, and 9. You can take out something higher than 3. You absolutely can take something out higher than 3. You can try it, Christian. Do it with 3 and see what happens. You'll figure it out. You'll visualize it. Yep. Yep, you're on the right track. Now, I'm going to tell you that there's something bigger than 3, but I want you to do 3 anyway. You can do 9, right? Absolutely. But your x and y's and z's are good. You could have kept it with 3. You would just realize that your coefficients can be factored in again. That's all. Okay, first step. The first step we did here was we looked at these 3 terms. And then we determined that the greatest common factor I could do by 4, 4, and 4, right? Okay, so write that down. Put a line through. That's a start, right? Don't be afraid to start there. Okay, now what terms are all in each one? X, Y, Z. Put it down. Put it down X, Y, Z. Take out at least one of each, right? Now what I want you to do is look at each x value and see if there's more than one that you can take out. 2. Yep, my lowest one is 2. So why would it be?
X is right.
That's good. What about y?
X is right, but Y. Your X is right.
3, 1, so 1 stays, yeah. And what about z?
I know, but like, so when it's still Y 6 then?
Okay. So now you're just taking each term and dividing it by 9, x squared, y, and z. Good. Good. 9, yep. We can all take, we can divide it by 9. Good. 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 No more?
So for every x, right, each one is divided by x squared, right?
Let's do.
What's the lowest x? It does not go over 18.
If you do not get the answer that's down,
never got your
something's up, okay? And ask for help, okay? But I want you to prove to me that's your answer, but I want you to prove to me that you can get to that part. That's okay. So keep working through it then. Keep working through it. Yeah, it is. Brianna, do you mind me asking you to repeat what I gave you?
You messed up.
I did? Where?
Oh, never mind. Yeah. Z. Wouldn't that be three? It would have been Z2.
Where?
The first one.
Oh, it would be. Yep. Yep, you're right. That's squared. Thank you. Brianna? 6 what?
Oh, I guess you don't have to put one.
X power of what?
4.
Y to the power of?
5 plus 81x squared. Y to the power of 5. Z to the power of 2 minus 9x squared. Z to the power of 4.
Okay, try that one. If you got time. Or if you're done. So not if you've got time. If you're done. You get it? Good. Awesome. Oh. Oh, wait a minute. You can't take X. You can't put that in here. You're telling me here that you can take it out. Remember, dividing here, you have to be taking something like you took 3. 3 only works for 6, 8, 1, 9. So you're saying here that X, Y, and Z can be taken out of all 3 of these. There's no Z here, so you can't take out Z. There's no Y here, so you can't take out Y. So you can only take out 3x squared. Make sense? Oh, yes. There's one variable in there, that's all. They're all 3 times. But the other 2 you can't. You're right. Did everybody get this first one? Can I move on to this one and kind of talk about the curveball?
Sure.
No? Okay, I'll give you more time.
This one's easy.
If you look here, you got X, Y. X, Y,
It's so easy.
and X,
There's only 3
What's the combination?
terms.
Only take out X. Make sense? You guys need help?
There's only 3 terms.
Okay. First step.
What?
This is going to start you with breaking down polynomials. If you're going to go
We
into
don't know it. What are we supposed to do?
and actually we put some context to it. When we talk about polynomials,
Get my haircut today.
I see your marker and I'm going to help you.
Oh, really?
You're going to look at this. So here we go.
You can't take out Y and Z. If you look here, there's no Z to take out, and there's no Y to take out. X is only here.
This is just the context of taking out common factors. When you get into actually our next piece is you're going to look at something like this. Okay, this is called a polynomial. On a graph, you've been dealing with grade 9. You look at graph like this, right? So linear graph. Yes. Remember grade 9? A little bit.
What's one?
Okay. This graph looks like this. Okay. I can tell your enthusiasm. This could be compared any kind of momentum throw a baseball. You can actually measure the height and distance based on the problem. That's why we do that. Okay? The whole, every measurement from shooting a basketball to hitting a hockey puck to throwing a football, kicking anything that has gravity, you can measure it using gravity. That's part of the reason why we use it. It's still very abstract at this point. In grade 10 it's very abstract. Because we don't get to put any context into, like I don't even have to show you the polynomials what that graph looks like. But I do, I tell you it's a graph and it looks like a curved line. The reason why I say that is for that question, why are you doing this? Here. Okay? Okay, so your first step. First off, there's a lesson here. Why we're not drawing stuff first. Okay? I look at 18, I look at 36, I look at the common number of all three of those. 9. So let's divide that. So write down 9. I'm going to divide 9 by each one of those. Okay. I have 3. Hold on. I look at my variables. All 3 of these have what variables? X, Z, Y, and X, Y, Z.
So divide
We're
6
going
by
to be able
3.
to factor out X, Y,
And then if you're
and Z.
exponents, all you do is subtract. So if you
Now I look at each individual X value. I have X to the power 5, X squared, and X squared.
because that's my thing of mine. It's because it's the
Or
common.
I can take at least 2 from each one, so I should go X to the
Like
power.
the divided by.
Okay, now I look at Y. What's the lowest variable?
Takes me over.
What do you have with me?
What's that?
What part?
That's the
So
same.
you know there's like this variable parts.
Y to the power of 1 is 1 by lowest one, so it's just 1. And Z. What is that? I got 3, 1, 4, 2. So now I take each term. And I break it each one. So 18 divided by 9 is equal to X to the 5th divided by X squared. X to the power of 5 divided by X to the power of 2 is equal to 1. So to break this down, 2X, 2. Same thing with Y. So you go Y to the power of 6 divided by Y to the power of 1. Y to the power of 5.
For your equation, you put like
And
this
Z
part.
cubed to the power of 3 divided by Z to the power of 1 is, nope, that's just another power of 2. Do the same thing for that one and then that one. And then you're done. You can't take a Y and a Z. Yes, you still have to write that down. He's right.
I'm glad.
Okay, looking at this one. You have X, Y, here. X, Y, Z. And you have X and Z. Which one is in all 3? Only X. You can't, I can't take out a Z here. There's no Z to take out. If there was a Z here, here, and here, I'd absolutely take it out.
So what do I do with the Z points?
You have to leave it. When you go to that point, you have to, the only one you can take out is the X. Does that make sense? Okay, I'm gonna wrap you guys up and we're gonna break this one down, okay? Because I want to move on. It's already 9:15, right? I got a lot to share with you. So let's jump to this one here that I put on the board. So 6x to the power of 4, y to the power of 5, plus 81x squared, y to the power of 5, and z squared, minus 9x squared, z to the power of 4. What's my first step?
See what you can divide by.
Good. So I'm going to figure out what I can divide. And what am I dividing first? My numbers or my variables? Let's look at my numbers. What number can I divide out 6, 81, and 9 by? I can take out a 3 out of all 3 of these. Now, I'm going to look at my variables. What variable or variables are in all 3 terms?
X.
X. Who can tell me why I cannot factor out X, Y, and Z? Why can't I take out Y and Z? Anybody know why? It's not in all 3. Is there a Z here?
No.
Is there a Y here? No. In order for me to have a variable down in the bottom here, they have to be present in all three terms. Just like this 3 is present in all three of the numbers, the variables have to be present in all three terms. I can only take out a 3 and an x. How many x's can I take out at a time? 2, because I have an exponent of 4, exponent of 2, and exponent of 2. So I can actually factor out 3x squared. What I want to also point out, this term, for a lot of you, we're starting to forget, we got to make sure that when we're writing our factors form, the first part of our bracket is always what we're dividing by. This exact same term needs to be the first thing you write down on your next line. Okay? To the point, 3x squared. Now I can start breaking down my factor. I've got 6x to the power of 4, y to the power of 5, divided by 3x squared. What's 6 divided by 3?
2.
What's x to the power of 4 divided by x to the power of 2?
X to the power 2. X
Can I do anything with that y to the power of 5? No, so I leave it. Y to the power of 5. My next one, 81. 81 divided by 3 is equal to, what is it?
26. 70. Is it?
54, 81. Yep, 27. Okay. X squared divided by x squared is equal to 1. So you don't have to write anything down. Y to the power of 5 and z to the power of 2, can I do anything with those? Kyle, what do you think? Can I do anything with those, that y and z? Because I don't have the y, z here? No, so I have to leave it. So I still put in y to the power of 5 and z to the power of 2. Good. Last one, 9 divided by 3 is 3, it's negative 3. X squared divided by x squared is just 1, and I can't do anything with the z to the power of 4, so I go z to the power of 4. Okay. Close my bracket, box it out. Here's my answer. Questions on that? Everybody good with that so far? You're going to have some time to work on it again in different assignments and tasks. I want to move on just so I can give you more examples. I also want to talk about, before we get going, I'm going to introduce the next piece. So the next part we're going to be talking about is actually being able to factor perfect squares. Jake had a really good question there, and he asked, why the heck are we even learning about this? Like, when am I ever going to use this element of factoring, this element of breaking down ridiculous numbers like this? Here's the example. We're going to be looking actually mostly at these. Okay? The examples that we just did were very abstract. It's the idea of being able to look at any polynomial you get and seeing if you can reduce or factor out a term. Okay? When you get to the point where you see 3 terms and you're like, oh, they're all divisible by 3, divide by 3. It makes factoring a lot easier. When we look at this term, I have x squared plus 4x plus 4. Question for you. In grade 9, you're used to seeing graphs that look like this, correct? Line graphs? No? You should be. You've done line graphs. You know slope? No? Yes, you've done slope.
Yeah.
Yes, you've done slope.
I don't remember.
I've taught grade 9, you've done slope. Slope is only done on linear rise and run? No? Nothing? Anyway, doesn't matter. Up until this point, you've only dealt with straight lines. Okay? This, if you were to put this into a graph, this graph looks like this. And actually it's flipped, because it's positive. It actually looks like this. A U. Okay? The reason why we have these types of formulas is it's the basis for any kind of objects adjusted by gravity. So for example, if I'm throwing a baseball, and I'm throwing it as far and as high as I can actually measure that distance through a polynomial. The curve of which, as long as I account for gravity, and the height, and the speed, and the time, you'll do those examples in 20-1, 20-2, and 30-1. Okay? So this is actually, the reason why we do this is when we factor it, you can actually find out when the start time was and when the end time was. Okay, depending on what you're measuring. So just a little bit of an insight as to why we even teach you this. is for when you get into grade 11 and grade 12. You all need a grade 11 math class, right, to graduate? So you're going to run into this again. And if you decide to pursue an engineering degree or a science degree or a kinesiology degree, you're going to want to know pieces of this, okay? So let's talk about how we break this polynomial down into its binomials or in factored form. Remember last day, if I gave you the example, x plus 2 and x plus 3, and I asked you to multiply them, I would get you to give me the area model, correct? What would I put on the outside of this area model? Who can tell me? What? X and 2 and x and 3. What would I do inside the rectangles? Tage? I would combine them. How am I combining them, Tage?
The x's?
Anything. How am I combining these numbers in here?
Multiplying?
I'm multiplying. X times x gives me x squared. X and 3 is 3x. X and 2 is 2x. 3 and 6 is, or 3 and 2 is 6. When I'm looking inside this area model, how many boxes inside this area model have the term x squared on it, or in it? One. There is one term that has x squared. How many terms are constants?
One.
No one.
1. And 6. The other two are the variable x. Okay. Keep this in mind. Now, if I want to go back, I'm going to put a little slide bubble for this because this isn't part of this example I'm going to do. I'm going to take the exact same approach when I want to work backwards. I'm giving you the polynomial. I want you to bring it down to this form. I still draw my area model. And I'm going to actually get you to tell me what are the two easiest points to write down inside the box. How many of them, which symbols are only seen once, or which terms are only seen once? X what? Squared. Where do we usually see an x squared at? Top, left, or right? Top left. In this case, I got 1x squared here. I'm going to put that right here. Where do I usually see my constant at? Bottom right. In this case it was 6. What's this one I'm going to write? 4. Alright. We're already halfway there. This should be something that you should be able to do for every single polynomial. If you know nothing about polynomials and factoring it, you should be able to draw a box and tell me what the first term is and what the last term is and where it is on these boxes. Okay? So test time, assignment time, whatever time, you should be able to do that in your sleep. Okay? Funny story, when I did calculus in my high school or my university year, I was doing derivatives in my sleep. It was like geeking out, like I'm not proud of that moment, but yeah, it happened.
Doing the what?
Derivatives. If you do calc 31, you'll
Is it x
Okay. So now I need to figure out what are all my I'm going back to factoring. What's the only two terms that I can multiply to get x squared? X and x. I'm going to write those right here. What are all of my potential terms, factors of 4? 2 and 2, 1 and 4. I'm going to use 2 and 2, and I'll show you why in a second. Well, good. 2 times x times 2 is equal to 2x. 2 times x is equal to 2x. If I combine everything in here, what term do I get? X squared plus 4x plus 4. Is that what I started with? When I have two terms separated here, and there's no symbol for x or 2, what symbol can I put in between here? What symbol can I put in between here? Plus. Can anybody tell me what the factored form of x squared plus 4x plus 4 is? X plus 2 and x plus 2. I'm just taking these answers and I'm putting them See where that's coming from? Anybody not see where that's coming from? Right? This x plus 2 came from here, this x plus 3 came from here. I'm literally doing the exact same thing, I'm only going backwards. X plus 2, x plus 2. Are you good with that? I want you to try another one. Coach me through this one. X squared plus 12x plus 36. What's my first step that I do? I draw my box. What do I put inside this 4 squared box? By the way, you will only have to deal with 4 squares in a box at all times.
What's the last number? 36?
36, sorry, there's the line going there.
X plus 6, x plus 6.
You're right. Now, just hold on. What am I putting inside the box right now?
X squared.
Where?
Top left.
What's the other number? What's the other term I can choose?
36.
36, bottom right. Fantastic. What is the only way I can break down x squared?
2x.
Not 2x, x and x. Fantastic, Taylor. What are my factors of 36 that I could try right now? 6 and 6. Do you notice the pattern that's happening here?
Yeah.
Compared to the last one? What are these two terms? They're the exact same, right? What are these two terms? They're the exact same. This is what's called the perfect square polynomial. Basically, they take two binomials that they're in factored form, they're identical. Okay? So let's keep going here. X times 6 is 6x. 6 times x is 6x. If I add these together, I get x squared plus, not 6x, 12x plus 36. Is that what I was looking for? So my final answer, because there's no negative symbol, I assume these are added. What is my factored form of x squared plus 12x plus 36? X plus 6 and x plus 6. This is one thing I didn't tell the other class. Another way to write this, remember whenever we said if I have one x and another x, and I can multiply them together, I can write x squared. If I have two of the exact same binomials, I can write it like that. That just represents that there's two of them. Okay? Both of these are a possible answer.
Say we would test make both if you circle one.
Totally okay. Okay, I want you to try this one. Not this one here. I'll get to that point, but I want x squared plus 22x plus 121. Go. Show me how you can factor that.
That would be. That would be 27.
What so far? Huh? Just started. Oh, that one.
Oh, there's y squared.
Okay. That's good. Good. Try x squared minus 22x. Okay, try x squared minus 22x plus 22. Good. So, original answer. Original what's your final answer? Okay. No, you don't need to write x plus 11. Just write it down. X plus 11. Yeah, write it down. No, x plus 11, not 11x. X plus 11. Literally all you're writing. No!
I'm just thinking.
You're literally writing x plus 11.
Oh.
How many times? You see it once here, and you see it. How many times do you see x plus 11 here?
It's just a bit of an addition.
That's literally all you have to do. This is right. You are right to this point. I need to see it in factor form. Okay? Remember? X squared minus 2xy. See what that changes. See if it changes anything. What is it? Okay, so let's go back up here. After I figured out this part was x plus 6 and x plus 6, I literally just put them side by side. So in this one, what do you have up in front?
What would be in between these two?
X and 11.
Would be another negative?
Yeah, so try it.
Positive on the outside.
And then write it how many
We have
times.
positive on the outside then if we do that.
And then you're done. Yep. Now I want you to do x squared minus 22. X squared, so just put a minus. Try that.
Would you minus here? So it's a positive.
But keep your x and still positive.
That's what I was thinking, so you'd be negative 11. I do it right. Yeah, that makes sense.
What's negative 11 times
Negative
x?
11.
So what's your polynomial?
Oh, it's just
X minus 11, not 11. And so we get rid of those x's.
Because once you multiply x.
Okay, so let's talk about this one very quickly. The original, I draw my box. I know which two numbers in my area model. X squared and 121. What factor of 121 do I want to try? 11 and 11, x and x. That makes 11x, that makes 11x. 11 plus 11 gives me 22. There's no negative, so I can assume that these are going to be positive. X plus 11 all squared is equal to my answer. I want you all to try this one. Some of you are already, but I want you to give it a try. The one that's on the board here. X squared minus 22xy plus 121y squared. The only difference is that you've got an extra variable in there now. You don't need this to do that. Yeah. What happens? Negative 11y. Because that would have been, if you would have kept that x, it would have been negative 11x squared. You're so close. So that's 11. You can't add those ones still be exact. No, that's right. You need to do that one. Is that 11 or 22? Okay. Yes, that's exactly it. Okay. So then let me try this one. You already said. Let's go x squared plus. Yep. Good. Well, what, that should be negative. Right, it's still positive. Yeah, that's a negative 11x. What do you need this to be? In order to make negative 22. That has to be a negative. So where is that negative? What's a negative times a negative? this has to be 11xy and that has to be 11xy. Yeah, so you need to put it, but you need to have it in your binomial. You don't have it here.
Oh, but it is, okay.
Wait, how did you get a number? Do you have? No, you still have the y squared. The y squared is like the squared, not the 1.1. 11. You need to at least to add up to equal what?
It's negative 11x.
In order for you to combine numbers, they have to have the exact same variable, so it has to be negative 11x. Doing alright? Sort of? A lot. Did you get the first perfect square ones?
Walking better.
The first one we did?
It's mostly just when
Yeah.
I start. Like,
This is
if I've been
like
sitting for a
a
while,
little bit more.
it's like right on the inside of my knee on this
You're
side.
getting stuck, aren't you?
So bending it doesn't hurt. It's
Probably
just
just stop it from this.
looking
You
for
can,
mitts.
yeah, but you still need to have that. Well, not so, you already have the x, right? Hi.
I still don't have so.
Don't prove it the x. Don't prove it the x. Nope. You can put it there. Say it on the front. Very good one, Joseph. Good, good, good.
Yeah.
Alright. Okay. I don't need these ones. You've got 1 and 14. You've got 1 and 14. I think you're gonna add, these two you're gonna add equal, right? Which one of these two? You will put them in. We'll add these. 1 and 14 or 2 and 7? Okay, 2 x's. So what, so this makes x. Ah, there you go. So now all you're doing is you're taking what you know about perfect squares and adjusting it. Yeah. So that's good.
Just
So
tomorrow,
then that
it's
actually.
right side video wants to go there.
Like, do your little cut thing.
You put the square inside bracket. Okay, let's talk about this.
It's hard, just like that.
Alright, let's talk about this last one here. Okay? We had x squared minus 22xy plus 121y squared. First step. Box out. Next step is what? What do I write?
X.
X squared and 121y squared. What terms multiply to give me x squared? X and x. What terms multiply to give me 121?
Negative 11.
Well, hold on. 11 and 11. What two terms multiply to give me y squared? Here's how you get your y in there, right? You have to make sure that not only do you have two terms that multiply to give you 121, but also multiply to give you y squared. That has to be y and y. Now, I need these two terms to add up to give me what? Positive or negative 22? Negative. So these have to be negative numbers. How am I going to make those numbers negative? I have to make 11 negative. X times negative 11y is negative 11xy. Negative 11y times x is negative 11xy. If I add all that up, does that make negative 20 x squared minus 22xy plus 121y squared? Does, if I add all this up, do I get, what do I get? X squared minus, what's 11 times, what's negative 11 minus 11?
0.
No, negative 11. I owe you $11 and I asked for another $11. I owe you 22 bucks plus 121 y squared. Is that what I started with? What's my final answer? X minus 11y. X minus 11y. Everybody good with that? So, somewhat. That's a difficult one, okay? The idea of having two variables is tricky, okay? Does everybody get a good grasp on these examples? The ones with just one variable, perfect squares. Awesome. Here's your first curveball. 2x squared minus 11x plus 9. Here's the thing, nothing changes. The first step is what? What have I done so far? Because the first thing I do, talk to me. Draw my box. What two terms do I put in first? I'm going to put 2x squared here, 2x squared, and what other number? 9. What did I do with this box here? I have to find factors that make 2x squared. What factors are there of 2? There's only one. 1 and 2. I'm going to put 1 here. I'm going to put 2 here. What two terms multiply to give me x squared? X and x.
Do you have to put the one?
No, you don't have to put the 1. If you know that that's just x, for sure. Again, to help introduce, to show that 1 times 2 gives me 2, I like to write that 1. What about 9? What are some factors of 9 that I know?
3.
1 and 9.
1 and 9, 3 and 3. Which one do you want to try? Let's do 3 and 3. We've been doing that one all along. So let's do 3 and 3. Okay?
Didn't you usually don't you put those numbers in the middle one?
Eventually. Hold on. You're gonna see my you're getting ahead of the game here. What's 1x times 3? 3x. What's 3 times 2x? 6x. If I add all this up, do I get the term I'm looking for? No. So I got a problem, right? Let's rethink this. What's another factor of 9 that I can use? 9 and 1. And I'm going to put the 1 here and the 9 here. Now, by the way, I need my two terms in here to add to give me a negative number. So what value should these be? Positive or negative? They should be negative, right? If these are negative, how do I adjust that outside my area model? If these are negative, where do I put the negative sign? Outside. By the 9 and the 1. What is 1x times negative 9? Negative 9x. 1 times 9 is 9. X times nothing is just x. 2 times negative 1 is negative 2x. If I add this all together, what do I get? 2x squared minus 11x plus 9. Is that what I started with?
Yeah.
What are my two binomials now? How can I write those out? 2x minus 9 and x minus 1. Here's where you are going to be doing some trial and error. You're adjusting your area model so that it fits your polynomial that you're dealing with. Right? I want you all, you've got 9 minutes to give this guy a try. 3x squared minus 17x minus 56. Okay? Show me that you can do this one, right? If you can do these two, you can do literally any polynomial factoring that we will do in this course. I guarantee you that. Because the one I showed you, Jake, is a heck of a lot easier than this one. Right? Absolutely, you're allowed to come and focus.
No, Jade, you're not. Everyone else is, but you're not.
Tage, we're all friends here.
No, we aren't. I'm not friendly.
Ouch. That's on recording now.
Yeah.
Tage is a salty mood today. She's eating a lot of it.
Well, it's squared otherwise. And this is
First thing you can always do is put in those negative 56s. Alright. That 3 is more complicated. Okay, what's my first step? Just because I know I'm running out of time, I want to give you a little bit more time to kind of nut this one out. What's my first piece that I can do?
Just draw the box.
Draw the box. I love that you guys are bringing this up. Mostly everybody had this part written down. What's the next piece that I can do?
3x squared.
And?
56.
Positive or negative?
Negative.
Thank you. Alright. Next step. What can I break down? What's the easy factor?
3x and
3x squared can make 3x and x. Awesome. Now what's my curveball? Where's everybody stopping at?
it's because the 17 is smaller.
That 56 is a bugger, right? We need to try to find something that's going to give me negative 17.
I thought the one at the top of the other one's going to
What's that?
the other one that we can also do is x.
You can flip flop it, it's fine.
No, but Mr. Dillon, I just said 8 and 9 because
8 and 9? 8
Yeah.
times 9 is not going to be 56. Gives me 72.
7, 8, and 7.
7 and 8, okay? Try 7 and 8. Everybody try 7 and 8 and see if you can adjust 7 and 8. I'll tell you that your factor that you're going to want to use at 56 is 7 and 8.
And then see what I have because they're all negative if you subtract.
Well, you need to have one positive and one negative, right?
Yeah.
Try it. I'm giving you the hint. 7 and 8 are the factors you use. Where you put the 7 and the 8, you need to determine that. You also need to determine, you have a negative number here. What number, or if you have a negative number here, what symbols need to be here? Positive, negative, 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 positive, positive. What do you mean? Negative, positive. Go. You need to combine somewhere a negative and a positive, a 7 and an 8.
Wait, it's
Trial and error. So it's still going to be 8 and 7. You don't need a 9. The 9's not going to work. So one has to be positive, one has to be
Doesn't work. Ours is better.
7 times 9 gives you...
I don't think
You said it, and I was like, okay, come
Oh
on.
my god. Yes.
Okay. So try... okay. So now, give me the binomials. So, like I said, this is where you don't be afraid. We're working on desks. It's not a big deal if you make a mistake. Work out what 3 times positive and 8 is. What's 3 times 8? 24.
8 times 24.
Yeah.
7 times
You
3.
take negative 7 times
24.
4, you get positive 7.
You guys all got ready for your answers with zeros.
Still, we wouldn't probably go back.
Right? You have positive 17 and negative 17. Now try. Perfect. Yep.
I don't take anything that I take this, but maybe it's
So we just said this is negative 7 and this is problem with that is that I add the
What? I don't really need things for
I need
no.
what if I switch
But if James, if I like less than all this, then I just.
Why?
3 times negative 8 gives me back. Yes.
Oh, wait. What's 24 subtract 7?
Yeah.
No, that gives me positive 17. Minus 8.
Oh, and what if it's 3x plus x?
No, no.
Minus
Do
what?
you see why it's like, why it's a little bit
It does work.
Makes sense a little bit?
Is this one plus?
Okay, very quickly before the bell rings. What was my combination that I needed to add? I need to have a Near this x, I needed this to be a positive 7, and with the 3, I needed this to be
-8.
negative 8. If I multiply these together, it gives me negative 24x. This gives me 7x. Negative 24 plus 7 gives me negative 17. My final answer is equal to 3x plus 7 and x minus 8. Guys, girls, just before the bell rings, that question will be one of the most difficult ones you'll see in this course. If you can solve that with this area model, you can literally solve any problem in this course. Alright? Because we're going to get to the next ones that we do. Jake is the ones that we show with you. Make sure that your desk is cleaned up, that the markers are put away. Before you go, have a wonderful weekend. See you next Abby, you shut off my recording?
Emily Bardak to the library, please. Emily Bardak.
It wasn't recording.
Really?
Yeah. I'm just playing.